Continuing on, I'd like to do an example of a data sufficiency problem. As I recommended earlier, you can pause the video at this point and try to solve the problem, and then I'll go on to explain it. So, if Pat saved $600 of his earnings last month, how much did Pat earn last month? Now, the unknown quantity, the thing that we're trying to find, we're going to assign our variable to be that. So I'm going to call X is going to be Pat's earnings last month. And then we're going to start by evaluating statement 1. Statement 1 says, Pat spent 1/2 his earnings last month for living expenses and saved 1/3 of the remainder. So writing that algebraically, we're beginning with Pat's earnings, and he spent 1/2 of that. We're going to represent that by X times 1/2. Now in turn, of that quantity, he saved 1/3 of the remainder. So multiplying that quantity by 1/3 is going to give us the amount that Pat saved last month. Now the question stem itself tells us Pat saved $600 of his earnings last month. So that whole expression is going to be equal to 600. Simplifying it, we're going to get X times 1/6 is equal to 600. And then simply solving for X, we're going to get X equals 3,600. In other words, Pat earned $3,600 last month. So since we were able to get a single discrete value for X and answer the question, statement 1 is going to be sufficient. And the correct answer is going to be A or D. Next, we have to evaluate statement 2 independently. Remember, we have to block out the information from statement 1. So statement 2 says, of his earnings last month, Pat paid twice as much in taxes as he saved. So we know how much he saved. We know that he saved 600. And statement 2 is telling us that he paid 1,200 in taxes. However, from these two quantities, we're not able to get a value for X, or we're not able to set up an algebraic expression that will let us solve for X. So statement 2 is going to be insufficient to answer the question, how much did Pat earn last month? Now we've gone through the method, we've determined that statement 1 is sufficient, and statement 2 is insufficient. And therefore the correct answer choice is going to be A. Now just to reiterate the problem we just did while using the flowchart, we began by asking, is statement 1 sufficient alone? And we answered yes. And so therefore we know the answer at that point was A or D. We then asked, is statement 2 sufficient alone? And we answered no. And so the correct answer choice was A. And as you do more example problems, using this flowchart will become second nature to you. Now, as mentioned earlier, there are two subtypes of data sufficiency questions. And those are yes-no questions in which they ask something like, is X an integer? The second are value questions in which they ask something like, what is the value of X? The first question type are yes-no questions. And these are questions in which they ask something along the lines of, is X an integer or is X odd? Now, as you're answering these questions and evaluating the statements require a single answer, either yes or no, to be sufficient to answer the question. If a statement gets you down to sometimes yes, sometimes no, then that statement is insufficient. In other words, if the question was, is X an integer, and the statement definitively told you yes, X is an integer, then that statement would be sufficient. However, if the statement told you sometimes X is an integer, sometimes it's not an integer, then that statement would be insufficient. And I'd like to do an example to make this more clear. Here's an example of a yes/no question. And as I recommended, try pausing the video and answering this one. Okay, so let's go ahead and solve this one. If n is an integer, is n plus 1 odd? Now what the question stem is really asking on this problem is n itself an even number? There are several number properties of odd and even numbers which are frequently tested on the GMAT. And when it comes to addition, it would be helpful to memorize these properties. For instance, an even number plus an even number will always equal an even number. An even number plus an odd number will always equal an odd number. And two odd numbers summed together are going to equal an even number. And it helps to memorize these properties when it comes to addition and also for multiplication. But in this case, we're considering addition. When they ask, is n plus 1 odd? It's really asking, is n itself even? Because you're adding an odd number to n. So we have to evaluate the statements individually. Now statement 1 tells us n plus 2 is an even number, or an even integer, rather. So what that's really telling us is that n itself must be even, because you're adding an even number 2 to n and winding up with an even integer. So if n itself is an even number, then n plus 1 will be odd, and you're able to say yes, n plus 1 is odd, and statement 1 is going to be sufficient. Therefore, the correct answer choice is going to be A or D. Next, we're going to evaluate statement 2 independently. Statement 2 says n minus 1 is an odd integer. Well, this also tells us that n itself must be even, since you're starting with an even number, subtracting 1, and ending up with an odd number. So n itself is even, and then n plus 1 must be odd, and this statement will also be sufficient. So therefore, the correct answer to this question is D. Now here is a second yes/no question. Is x an integer? Go ahead and solve it. Now the question asks, is x an integer? And of course we know that integers are defined as the set of whole numbers that have no decimals or fractions attached to them. And integers can be negative, they can be 0, or they can be positive. Now, as we evaluate statement number 1, it tells us that x over 2 is an integer. And basically what that's telling us is that x itself must be an even integer, because the values that you could plug in for x, where x over 2 is an even integer, are numbers like 4, 8, 12, any values like that. You could, in order for statement 1 to be true, you really can only plug in an even integer value. So you're able to definitively say, yes, x is an integer, and statement 1 is sufficient. Therefore, the answer is going to be A or D. Statement 2 tells us that 2x is an integer. Now, the problem with statement 2 is that x could either be an integer or it could be a decimal. You're able to plug in values like 2, in which case, sure, x is an integer, but you could also plug in a value like 2.5, because 2.5 multiplied by 2 will give you an integer result. So x itself could either be 2, or it could be a value like 2.5. And so when you ask the question, is x an integer, the result you get is sometimes yes, sometimes no. So therefore, statement 2 is insufficient to answer the question, and the correct answer choice will be A.